In the previous video, we deployed a microservice in a Kubernetes cluster using Google Kubernetes Engine. We are going to use the same application in this video to illustrate the various ways of deployment in Kubernetes cluster. In the previous video, when we executed kubectl create command on a deployment configuration file, what happens first? A deployment gets created, which in turn creates replica sets and pods. A replica set is responsible to make sure a certain number of pods are always up and running. Then, service gets created to make sure those pods are accessible to other services. Now let's talk about a few deployment strategies that we can implement while deploying our application into the cluster. Actually, there are a few deployment strategies to consider, but I'm going to focus in this video on only three well-known deployment strategies. One is what we call rolling update, one is blue-green deployment, and another one is Canary deployment. So let's talk about rolling update first. When working with Kubernetes, it's necessary to update the application from one version to another. With rolling update deployment strategy, application moves from one version to another version through the process of creating a new replica set, which slowly increases the number of replicas in the new replica set while decreases the number of replicas in the old replica set. Let's update our voting application by editing one of the deployments which displays the voting page. Now, change the image mentioned in the container section with version 2. Save the file and exit from there. The deployment has been updated in the Kubernetes cluster, and Kubernetes will start a rolling update. We can see the new replica set with kubectl get replica sets command. We can also check rolling update history with kubectl rollout history command, followed by the name of the deployment. While running the rolling update, if we find any problems in the deployment, then we can pause the rolling update straight away with kubectl rollout pause command. And once the issue is fixed, we can resume the rolling update with kubectl rollout resume command. We can also have a look at the status of the latest deployment with kubectl rollout status command. In some cases, although the rolling update has been completed successfully, we might find bugs in the newer version of the application, and we want to move back into the previous version of the application. That can be done with kubectl rollout undo command. So that's all about the commands that can be used to deal with rolling update type of deployment. Now, let's talk about the blue-green deployment. Rolling updates are ideal for scenarios where we want to deploy an application slowly with minimum downtime and minimum performance impact. There are other scenarios where it is even more beneficial to modify the load balancer pointing to the newer version only after the replicas have been fully deployed. In that case, blue-green deployment is needed. It can be done with Kubernetes by creating two separate deployments. One for the older version, marked as blue version, and another one is for the newer version, marked as green version. To illustrate the blue-green deployment, we will use our existing vote deployment for the blue version. This deployment is accessible via a load balancer service. Once the newer green version is up and running, we will update the service by pointing to the newer version, which means the green version. Now, let's create a new green deployment for our new version. For this version, we are going to use version 3 instead of version 2. And also in this deployment, we need to update the app label to vote_green. Now let's create the deployment with kubectl create command. Now the green deployment is up and running, But in the browser, we can still see the previous version, which is version 2. To make the latest green version visible to the users, update the service to point to the new version with kubectl edit service command. When the service gets updated, the green deployment will be used immediately. We can now verify that the newer version is up and running in the system. If necessary, we can roll back to the old version in the same way by just updating the service back to the older version. That's all about the process of applying blue-green deployment in the Kubernetes cluster. Now I will finish this video with Canary deployment. Canary deployment is that kind of deployment that allows us to release a new version to a small subset of users before this new version is considered a stable version. And this Canary deployment can be used to minimize the risk associated with the new version. This Canary deployment consists of a separate deployment with a new version and a service that points both the stable deployment as well as the Canary deployment. First, let's scale our stable version into 5 instances, and then create a new Canary deployment for the new version. Let's name it vote_canary. And let's say it's using version 4 now. Make sure the number of replicas is 1, or at least less than the number of replicas of the stable version. Apply the kubectl create command to this new Canary deployment. After the Canary deployment is created, we should have 2 deployments. One is pointing stable version and another is for the Canary version. Also, make sure in the voting service, the value of label app is vote in the selector section. Because of having fewer number of pods in the Canary deployment, it will be visible to fewer users. Now we can check the Canary deployment by refreshing the page several times. We will see most of the cases, version 2 is returned, while for a small set of occurrence, version 4 is returned. That concludes the successful implementation of Canary deployment. Before I finish this video, let's talk a little bit about session affinity that might be related with any kind of the deployments we talked about in this video. When a new version has been deployed, there is a chance that the user interface for the application has been changed, and users might get confused with these new sudden changes. In that case, we want the user to stick to one version. We can let our users get rid of this kind of confusion by updating the service with session affinity that's set as client IP. That means all clients with the same IP address will have their requests sent to the same version of the voting application. So that's all about this video, where we have gone through an in-depth, hands-on lab practicing deployment management with Kubernetes. We have also learned the use of kubectl rollout command while dealing with deployments in Kubernetes cluster. In the following video, we will go through the process of setting up continuous delivery pipeline with Jenkins in Google Kubernetes Engine.